Hi, my name is George Mormasato, and I want to demo the GridWhale file system. GridWhale is a computing platform that anyone can program. You write your programs in a browser, and they run on GridWhale's cloud infrastructure, taking advantage of as many processors as it needs. And programs, of course, need to be able to access data. They create files, they read files, they save files, and so having access to a file system, API is important. So I want to show that off here. In GridWhale, every user has. You can see I'm signed in here. This is my account. Every user has a home directory, and they've got a bunch of files and folders in here, just kind of like a normal, just like any old normal computer. I'm going to go into this folder where I'm keeping some of the files for demo 3. But you can see that I've got a bunch of files in here. And let me, if I just kind of minimize this, here I am on my Windows PC. I'm looking at GridWhale through a browser, but I'm going to just drag and drop some files. I'm going to drag and drop this CSV file into here, and of course it just uploads it. I mean, again, no big deal. And when I open it up, you can see this is just a CSV file, just a bunch of data about, let's say, asteroids. Looks like Ceres and Pallas, and it's just rows and columns. Not a big deal. It's exactly what you would expect. This so far what I've shown is, of course, not very interesting. This is exactly how Google Drive works. This is exactly how Dropbox works. I mean, there's nothing interesting. What's interesting here is that we can now write programs, and I'm about to show you, that lets you manipulate all this. So let's just start with this simple little program. This is a very, very simple little program that all it's going to do is list out the contents of this demo 3 folder. So let's just run it. And again, pretty much exactly what you expect. It's just printing out a list of files that are in that folder, and here they all are. Here's the asteroids.csv file that got added. And now what's interesting about this is, look how small this program is. This is a really, really very small program. Imagine what it would take to write a similar program to access, let's say, G Drive files, Google Drive files. There'd be all sorts of authentication you'd have to do. You'd have to deal with permissions and signing in. Even if you use the library, there's a bunch of things you'd have to set up to be able to get some of this. Here, what's cool is, because this program itself is running in the GridWhale cloud, and because GridWhale already has me assigned in, this program is running with my credentials and is able to just very, very quickly authenticate me and know what my home directory is, and very quickly access all that information. So from a programmer's perspective, being able to access the GridWhale file system is really, really easy. There's another subtle advantage the way this works. Again, if you think about how something like Google Drive would work today, Google Drive has a set of APIs that are internet facing, that are public APIs that let programs connect to and then access that data. And of course, that's why you need this layer of authentication to make sure that it's valid access. In this case, though, because the program is running inside the GridWhale cloud, there are no public-facing file system APIs. This call to access that directory is a call that gets run inside the GridWhale system and accesses files inside the GridWhale system. So at no point is there an API that is internet-facing. And so the surface area of the GridWhale API, from the perspective of the outside world, is much, much smaller, and consequently, much, much easier to secure. It's just a lot of things just get so much simpler when you have that architecture. So that's one advantage of having this cloud computing platform. Now let's again just examine a little bit about how this works. There's a API call here called data.open, and you pass it. You can see kind of a path. The tilde is kind of, again, very Linux-like, Unix-like system. It just kind of identifies your root, user root directory. Then just a couple of home directory, and then the actual folder. So pretty obvious, pretty easy how you would navigate and how you would do it. What's interesting here, though, is that this data.open returns essentially a handle to the directory, and once I get the value, with this second call, I end up having just essentially a table of the set of files that are in that directory, and when I print that out, that's where I get that listing. So again, it's pretty easy. That print just basically just generates that listing. Now let's do something else. Let's see. That's essentially a directory, but let's look at a different. Let's look at the actual contents of a file and see how we access that. So this is a slightly more complicated program because it has this dialog box that lets you pick a file. So let's try this one out. So the first thing this does is it brings up a dialog box, and this dialog box is essentially filled in with that directory that we saw in the previous program. I'm going to pick this file, right, asteroids.csv, hit OK, and then now it's going to print essentially that CSV file. It's going to just print the table of the CSV file. So again, super easy. Let's look at how this works. The core of it is again very, very small. We call this subroutine, which I will describe a little bit later, but we call this subroutine, which just basically says, let me pick a file out of this folder. We get back a file ID, a file name, essentially. And then look, we're doing the exact same call. We're doing data.open on that address. We're getting back some open file handle, a dataset handle. And then we do the get value, which just returns the contents of that file folder. I'm sorry, the contents of that file, the contents of that CSV file. And that's it, and then we just print it. So again, with very few lines of code, we've done some pretty cool things. We've popped open, file open dialog box. We've let the user pick a file, and then we've printed the contents of that file. The actual file open dialog box is not even that complicated. It doesn't do very much. I mean, compared to like a real file open dialog box, but even in this simple form, it's really pretty simple. You pass in some starting path, which is this. You do the exact same API data open to get the current directory, and then all I'm doing here is I'm creating a list box control and then associating that directory data to that list box control. So these two little lines of code are enough to display that directory in a list box, and then you're done. And then the only other thing I have is, when I bring up the dialog box, this code brings up a dialog box. There's an on action where I just define a function that basically I say when the user hits OK, just find out what the list box selection is and return that. So pretty easy. That's literally it. That's kind of how it works. So what I want to show now is that's reading a file. Let me show modifying a file. So modifying a file is not, again, as you might expect, not that much harder. This program is going to, I'm going to do the same thing. I'm going to pick a file through a dialog box. And then I'm going to assume it's a CSV file. And then I'm going to bring up another dialog box where I ask for essentially to add a new row, and then we're just going to add a new row. So let's just try it and see how it works. So I've got an asteroid.csv. Here it's asking me, okay, just type in a new row essentially. So I'm going to, some new asteroid, whatever, and we'll just type in some values here. I don't really know what the values would be for a new asteroid, but let's just go. And then we just print it, and here at the bottom you can see this new asteroid got entered as a new row in this document, in this CSV file, and this is persistent. If I go back to this file, which is the file that I just modified, you can see that at the bottom it got added. So this is just like a totally you are literally modifying the file. So let's look a little bit about how this works. It's pretty much what you would expect. We ask the dialog box to pick a file. We ask them to pick a file. We open it again through the data open, the normal procedure. we bring up a dialog box, and there's a couple interesting things to look at. This data open returns a file handle, but the file handle is basically an object that is different depending on the file type. So for CSV files, we get back a table object. If it were an image file, we'd get back an image object. If it's a text document, we get back a text document, a text object. Again, you get it, and of course the methods and properties of that object, of the object that we get back, depend on the type of file. So for a CSV file, we're going to get one of the properties we get is schema, which is kind of essentially the columns of that CSV file. It just tells you what the columns of the CSV file are. That's the schema property because it's a table, and it's also got an insert method. So now I can insert a new row. So the fact that this is a CSV file gives us a table object that has these specific properties and methods. The UI dialog box command basically takes a schema definition and automatically generates fields based on that schema. That's why when I ran it, when I run this, these fields are automatically set based on the columns of the particular CSV file. That's why I didn't have to do anything. You notice nowhere in this program am I defining any of those fields. It's because they come straight from the CSV file. If I had picked a different CSV file, I'd get a totally different schema. So that's how it works. Then if new row, meaning if you didn't hit cancel, new row ends up being just the set of new data that you typed in, and then I just do the insert call and I insert it, and then at the end, I just print it. So that's it. The cool thing is, again, with a very small number of lines of code, GridWhale, the underlying system, just handles all the really hard parts. It handles file types, it handles schemas. It's all that stuff is what helps a developer to save time. From the developer's perspective, they just don't have to work nearly as hard to get some pretty decent results. I'll show you, another quick example. If I go, let me upload something else. I'm going to upload an image. Everyone always says your demos go better if you show images of puppies, so let's try that. So I've uploaded, an image, and then I'm just going to use the same program that I used before. Let's, just remind you how it works. It basically just, you pick a file to open, and then, load it, and then print it. So let's run it. So this time I'm going to pick the image instead of the CSV file, and when it works, it took a little bit to load, but once it loads, there's the image. So I did the exact same code, but this file handle is now an image object instead of a table object, and that's why when I do a print, you end up with an image instead of a table. So GridWhale is smart enough, the system is smart enough to understand these file types and to have the appropriate set of objects to deal with them. So that's what makes this system so productive. It's just really easy for developers to do things. Now I'm going to show one last thing. The thing about file systems, files are a shared resource, right? So files, you would think that it'd be really easy for two people to work on the same file, but in traditional file systems, that's actually super hard. Because generally once you load the file into memory, well, now that memory is kind of under that program's control, and if somebody else loads that file, well, they get a totally different copy of that memory, and now you're on your own trying to synchronize it. Now you got to write all this code at the app level to try to synchronize these two files to make sure that when they change, you get notifications. Well, in GridWhale we do things we do it differently because sharing is such a common scenario and such a interesting scenario that we want to make sure that the GridWhale handles that. So let's imagine. Let me go back. Let's take this asteroid document. Oops, and I'm just going to open it. And so now this table is basically, effectively, a program running that is displaying this table. But now what I'm going to do is I'm going to go. Let me open another tab. We'll even do it like this so that we can see everything. And so here's one program running. Now I'm going to go back to this program that modifies that exact same table. So I'm going to run this program, and I'm going to pick that CSV file, and then I'm just going to add a new asteroid. So another one, oops, another asteroid. Beautiful. Okay. And sure enough, look at that. Automatically, it got updated in this table. Every time I modify it, it's just going to do the same thing. There it goes. It adds another version. This is kind of a live version. So let's look at this, because what's interesting, the question is, well, how did that happen? How did that work? This is all the exact same code that I showed. We basically, we open the file, and then we modify it. So what's going on under the covers? What's going on is this file, this data open command, this data open call. What it's really doing is, in GridWhale, it's creating an area. It's creating some bit of shared memory, some object in shared memory, not necessarily in this program's process, and then it returns a handle to it, and that handle, then, whenever you manipulate that handle by, let's say, doing an insert, we do a remote procedure call to wherever that shared object really lives, and then do the modifications there. The GridWhale system kind of just handles that, so you don't notice that. You're just writing code saying, insert, insert, insert. You don't really know, or you don't really care how the insert is actually happening. In actual fact, the insert, could be happening on a piece of shared memory on a totally different computer in the data center, a totally different machine in the data center. Now, when a different program opens that exact same file, it's just going to get a second handle to that piece of shared memory. And whenever that piece of shared memory changes because of this insert call, it's going to get a notification. So this guy, when I'm inside this program and I'm displaying this, whenever a new row gets added, the program gets a notification. The process gets a notification telling it, hey, this piece of data changed. This handle changed. And because of that, the GridWhale automatically takes care of updating the view. So let me just show you one other thing. I guess you can do it in this one. See how right here there's a call that basically connects the list control. Here I've created a list box. It connects the list control to this handle, to whatever handle is returned by data open. So that connection between the list control and the open file, the file handle, is enough for the GridWhale system to automatically update the list box when that file changes. So without adding any extra code, there's no extra code here that the programmer has to worry about. Anytime that file changes, the UI automatically gets updated. Now, of course, if there are cases where you do want to have control and be in the middle there and to have some kind of notification, there are ways to basically register for on change events. So I can do something like I can actually do something like over here. I can do file data set on change and give it some function, which in here I can do something when that file data set changes, and that gives the program a chance to react when the file changes. But even if you don't do that, without having to do that, things automatically change. So this, like I said, the list box automatically updates. This data automatically updates. So the next time you call get value, you're going to get a new value, a different value. So all that is handled for you. All that is taken care of. That's what, in my opinion, that's what makes the GridWhale system and the APIs and the abstractions that are underneath it, the platform that's underneath it. That's what makes it such a powerful system for creating applications. Those are the kinds of things that I think make it much easier to build, robust, pretty awesome applications. I mean, just think of how hard it would be if you had to recreate all that code using today's technology. It's actually be super hard to try to do all that, and then get it to scale out to as many, however many users you want. It all like has a cost. But GridWhale, the magic of the platform is that it handles all that for you. All right, well, that's it about the file system. Thanks for watching. GridWhale is, like I said, a computing platform that is just aimed at getting developers to be more productive with these kinds of web apps. And bit by bit, we're working on all the little pieces. I'm demoing the file system, but there's a ton of work to be done on the user interface. There's a ton of work to be done on other parts of the platform, and bit by bit we're just working on all of it. And over time I'll be doing more of these demos. If you're at all interested in knowing more about GridWhale, you can try this out. GridWhale.com. It's pretty buggy still. It's pretty early. It's very prototype. But GridWhale.com. You can try it out. You can also contact us as contact@chronosaur.com. And if you're interested in knowing more about it, just drop us a note and we'll talk. All right. Thanks very much.